In this video, we will be talking about the intersection of the functions. Consider the graph of a quadratic function and a linear function on the same set of the axes. There are three possible scenarios. The first one is where a linear function is cutting the quadratic equation. It's going through the parabola. In that case, we have a 2 point of intersections. Vocabulary term here is cutting, and it has 2 intersections. Another case is when a line is just touching the parabola at one point. These are called tangent, or we say touching at one point. Last case is when they are not intersecting at all. We say they are missing each other, and there are 0 point of intersections. When two graphs are intersecting, the value of x and y are the same at that point. We need to set two equations equal to each other and solve for x and y. Given y is equal to x squared minus x minus 18 and y is equal to x minus 3, find the intersections. We're going to set two equations equal to each other. X squared minus x minus 18 is equal to x minus 3. Move all the variables and numbers on one side. So we have x squared minus 2x minus 15 is equal to 0. This function is factorable. We have x minus 5, x plus 3 is equal to 0. That means x is equal to 5 or x is equal to negative 3. So those are going to be the x-coordinates where two functions are going to intersect. To find the y-coordinates, we want to plug in the 5 into either of the equations, but in this case, plugging over here will be a lot easier. So we have when x is equal to 5, y value will be 2. When x is equal to negative 3, onto the same thing, we have y value is equal to negative 6. So those are going to be the two intersections on those two graphs. If we were to graph this, the quadratic function has a y-intercept at negative 18. Since a is equal to 1, it's concave up. So it's going to be in some form of a function like this. For the linear function, we have y is equal to x minus 3. The y-intercept is at negative 3. And we know the slope of this linear equation is equal to 1. So that's a positive slope. So we're going to have a function that looks somewhat like this. See, we have 2 point of intersections, where the first one, negative 3 and negative 6. And then the second one on the right side will be 5 and 2. So for x, let's subtract all the numbers and variables on the left side. So we're solving for 0 is equal to x squared minus 3x minus 10. This one is factorable. 0 is equal to x minus 5, x plus 2. Therefore, x is equal to 5 or negative 2. For the second equation, it looks exactly the same except that this problem deals with an inequality. So we have 0 is greater than x minus 5 and x plus 2. In other words, if we wanted to move this onto the other side, that means this has to be less than 0. So creating a sign diagram where we're going to have negative 2 and 5. So we're going to substitute the values that are less than negative 2, such as negative 10. Substitute the value that are in between negative 2 and 5, such as a 0. 0 is always an easy one. And then substituting a value that's greater than 5, maybe try 6. Now let's substitute the values. If we have x is equal to negative 10, we have negative 10, negative 5, that makes it negative 15, times negative 10 plus 2, that's a negative 8. So negative times a negative. Here again, I don't care too much about what the actual number is, but I'm curious to see whether it's going to be a positive y value or a negative y value. In this case, it'll be positive. If I plug in something like 0, you would be left with negative 5 times positive 2. Negative times positive, that's negative. If we plug in an x value of 6, we have 6 minus 5 is 1, and then 6 plus 2, that's 8, so that's going to be another positive number. We're trying to look for when x minus 5 times x plus 2 is less than 0. Less than 0, that's all negative numbers. So that must be in between negative 2 and 5. Remember, when it's negative 2 and 5, those are when it's going to be a 0. So we don't want to include that answer. So the final answer to question number 2 will be x is greater than negative 2, but less than 5. On the next slide, I'm going to show you how to do this problem on a calculator. There are two ways to approach this problem on a calculator. I just rewrote the question of x squared plus 5x plus 6 is equal to 2x squared plus 2x minus 4. We want to graph them separately, then find the intersections on a calculator. That's the first method, find the intersections on a calculator. Second way is by solving the equation equal to 0, then finding the 0 on a calculator. The first method that I explained on the previous slide is by typing the equation that y is equal to x squared plus 5x plus 6, and another equation 2x squared plus 2x minus 4. Write them separately. Then you're going to graph these two functions. Since mine is a colored TI-84, it tells me which one is blue and which one is red. Next, in order to find the intersections, you need to go second, calc, then number 5, intersect. You're going to move your cursor around the intersections. First curve, enter. Second curve, enter. Enter one more time to find the intersections. You're going to repeat this process one more time to find the other point of an intersection. Method 2. The other way to solve this equation on a calculator is by solving the equation equal to 0. So we already did this in a previous problem. So type in the function where that's equal to 0. So in this case, after you graph, you want to look for the zeros. So you're going to go second, calc, then 0. And we know this pretty well. You're going to move your cursor around that 0. Left side of the 0, click. Right side of the 0, click. Click one more time. And then there will be a value of 0 at negative 2 and 0. And then you repeat the same process for the one on the right side, and you find the other 0. Y is equal to 2x plus k is tangent to y is equal to 2x squared minus 3x plus 4. Find the value of k. We're given a quadratic equation that's concaved up. We're also given a linear equation with a positive slope, which is tangent to this quadratic equation. So that means it's going to intersect this quadratic at one point. To find the k, we're going to set two functions equal to each other, 2x plus k is equal to 2x squared minus 3x plus 4. Subtracting the 2x on both sides, we're left with 2x squared minus 5x plus 4. Subtract the k on both sides, minus k, they're all equal to 0. Here, again, going back, since the quadratic function and a linear function is tangent, that means they're going to intersect exactly at one place. Here we're given a quadratic equation that's equal to 0. Going back to the discriminant, when does it have only one solution? That's when the discriminant is equal to 0. So we want to solve for a discriminant and set it equal to 0. Discriminant is b squared minus 4ac, so that's going to be negative 5 squared, that's positive 25, minus 4a. c, in this case, we have 4 minus k, so you want to write 4 minus k for c. So we have 25 minus 8 times 4 minus k. Distributing negative 8, 25 minus 32 plus 8k. They're all equal to 0. 25 minus 32 is negative 7, so 0 is equal to negative 7 plus 8k. That's 7 is equal to 8k. Dividing by 8 on both sides, 7 over 8 is equal to k. So when k is equal to 7 over 8, we have a line tangent to a quadratic function.